let this be a normal field trip? With a friend? No way!
Cruising on down Main Street, you're relaxed and feeling good. Next thing that you know, you're seeing octopus in the neighborhood, surfing on a sine wave, swinging through the stars. Take a left at human testing, take your second right past Mars on the magic school bus. Alligator nostril, climb on the magic school bus. Spank a plankton too, on our magic school bus. Drop the river of lava on the magic school bus. Such a fine thing to do.
Miss Frizzle, where are we going today?
Well, Carlos, we're going to Six Flags.
No! Hey, Arnold, why are you so scared?
No, I'm deathly afraid of heights, especially on roller coasters.
Well, when you know what to expect when I show you, it's really not that bad. To the classroom!
So, the life is represented by the function f of x equals 2 sine x plus 25. So, to graph this function, we need to go through many different steps. And the first one is taking the derivative of our original function f of x. With that, we get, when we take the derivative of 2 sine x plus 25, we get 2 cosine x. Next, we have to set it equal to 0 to find our critical values. When you divide 2 over, you still get cosine x equals 0. And then you have to do arc cosine of both sides, and you're left with the values pi over 2 and 3 pi over 2, because that is where cosine equals 0. Secondly, you must test these on your f prime of x sine line. And here you're going to put your endpoints and your critical values that you just found. So pi over 2 and 3 pi over 2 are going to go here and here. Next, you want to find out whether, what's going on between each of these intervals, like 0 to pi over 2, and pi over 2 to 3 pi over 2, 3 pi over 2 to 2 pi. And when you need to figure out from 0 to pi over 2 whether it's positive or negative. And so you take any value in here and you plug it back into here because it's your first derivative test. And so from 0 to pi over 2, if you draw the unit circle, cosine is positive here. So we'll have a positive value. From pi over 2 to 3 pi over 2, here to here, cosine is negative, because if you had like x equals negative 1, that'd be negative. So there you get negative. And 3 pi over 2 to 2 pi is from here to here. And you would get a positive value. So this implies that so you basically say it's positive, negative, positive, and then you want to find, then that implies that f of x is increasing from 0 to pi over 2. From pi over 2 to 3 pi over 2 it is decreasing, and from 3 pi over 2 to 2 pi it is increasing. And you also want to figure out where your rel max and mins are. So since when you draw your arrow from here and here, you see it's kind of going up and then down, so it's a rel max here. And then here, down to up, so it's a rel min. So you get a rel max at pi over 2, 27, because you got to test pi over 2 into your original function, and that will get you the y value, which that's how we got 27. And your reasoning would be because f prime of x changes from positive to negative. Here, there's a rel min, 3 pi over 2. Test it into this function, you get 23, because f prime of x changes from negative to positive. So for the second part of this graph analysis, we must take the derivative of the derivative to get our second derivative, and that will inform us about the concavity. So the derivative of 2 cosine x is negative 2 sine of x, and when you need to set that equal to 0 to find your other critical values. Again, negative 2, 0, it equals 0. So sine of x equals 0. You do the arc sine of both sides, and where does x equal? It equals at 0, pi, and 2 pi. Then you graph these values on you put them on a sine line. So you have 0, pi, 2 pi. You take a number from 0 to pi, so pi over 2, or how about pi over 3? And you plug it in your second derivative here. So we would get a negative value. And thus we'd have f of x being concave down. From pi to 2 pi, you take another value and you plug it in here. You get a positive number. And thus f of x is concave up. So what does that mean? It means that there is a point of inflection at pi, 25, and you get the 25 because you take this pi and you plug it into your original function. And because f double prime of x changes sign, there exists a point of inflection at this value, and that just means that the concavity changes there. So from the information that we've taken from from making sign lines for our first and second derivatives, now we can make a big F sign line and graph all this information onto one so we can see everything clearly. So we're going to put our critical values for our first two derivatives, and see we'll have here 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So after that, we'll just move all the information that we got from the individual derivatives and move it down to here. So here it'll be increasing, decreasing, decreasing, increasing, and then concave down from 0 to pi, so concave down from 0 to pi, and then concave up from pi to 2 pi, so pi to 2 pi. So after that, we're going to find some of our y values to let us get a bit better picture of the graph. And so when we plug in pi over 2 and 3 pi over 2, we got 27, 23. When we plugged in 0 and pi, we get 25 and 25. And when we plugged in f of 2 pi, one of our endpoints, we'll get 25. So now you're just going to make a huge graph, and you're going to plot all your points that you got from here. So at pi over 2, it is 27 meters in the air. So once you've gone a distance of pi over 2 meters into the ride, you are 27 meters in the air. At pi, you will be pi distance into the ride and 25 meters into the air. At 3 pi over 2, you'll be 3 pi over 2 meters into the ride, 23 meters high, 2 pi, 25 meters high. And so to figure out, so that's when you graph your points. Now you want to figure out what lines are you drawing. So to figure out the lines, you see it's concave down and increasing, so it'll look like this. It's concave down and decreasing, so it'll look like that. It is concave up and decreasing, so it'll look like this. And then from 3 pi over 2 to 2 pi, it's concave up and increasing, so it'll look like that. And then you graph on your little intervals right here. You'll just match up whatever lines you drew and just draw them over there. And so this will just tell you, your x distance will just tell you the meters you're into the ride, and your y will tell you the meters, how high you are into the roller coaster. So, yeah. Okay.
Now that you understand the math, Arnold, let's go to Six Flags.
Okay, I guess I'll try it.
See guys, curve sketching makes everything fun. Yeah. Class, wrapping this fun field trip day up, I hope you all learned a lot about curve sketching. Bye, see you tomorrow.
Just to make your day complete. You might get baked into a pie.